Welcome. In this module, we are going to take a look at SQL, which is structured query language. So, we are going to understand what does it mean when we say it's a declarative language, right? And then we are going to see SQL query order of construction with some examples, and finally end the discussion by understanding SQL joins. So, let's get started. Let's start by defining SQL. SQL stands for Structured Query Language. So, SQL includes both data definition language (DDL) and data manipulation language, which are DML statements. So, data definition language include queries that help to create, alter or drop a table in order and modify the schema of a database. Whereas DML, the data manipulation language, looks at select, insert, update and delete, which is statements that are used to manipulate data in a table within the database. So, select something from some table where some conditions are satisfied is a typical format, right? And update some table sets some specific attribute where some condition is satisfied. So, these are typical DML statements. So, what can SQL do? It can help to execute queries against a database and retrieve data from a database. So, that is why it's called declarative, because the way SQL is written, it is aimed to extract information in of a particular condition. Of course, you also have queries which will insert records into a database, update records into a database, delete records from a database and create new databases, new tables in a database, create store procedures and views in a database. And of course, last but not the least, your RDBMS also requires to do specific access for different users. So, there are SQL statements that can also help us to set permissions on specific tables, procedures and views. So, the structured query language is a declarative query language. So, what does declarative mean? Declarative, as we just saw in an example of the DML statement, declarative just means that it is more general in manner and involves broad instructions. It just gives the task that needs to be completed rather than the specifics on how to complete it. So, some of the positives of declarative query is user expresses what data to be retrieved, not how it needs to be retrieved. The engine underneath takes care of seamlessly retrieving. All the logic of the specific is taken care by the engine. So, well-known general declarative programming languages are SQL, you have Haskell, Ruby, etc. Right? So, generally declarative languages are more general in nature, in giving broad instruction on what needs to be done, not on the specifics on how to complete it. Whereas there are some negatives of declarative querying as well, because user has little to no control over how inputs are dealt with, right? So, you just pass on the query. The performance of the query, of course, you can manipulate by some of best practices in the query, but for the most part, the engine takes care of executing the query and returning the results. If there is a bug in the language, the user will have to rely on the provider of the language to fix the bug. Right? And if the user wants to use a function that the query language does not support, they are often at a loss because there might not be a lot of user-defined functions. In a typical structured query language query, there is an order of construction. So, in this module, we are going to talk more about how SQLs are used to retrieve data from a database, right? So, your SQL statement that is used to retrieve data from a database starts with a keyword select, and it helps to pick the columns or the attributes corresponding in a particular table from points to the table where it puts filters on the rows, right? And group by helps us to aggregate across values of a variable. Having filters aggregated values after they have been grouped. Then order by sorts the results, and finally limits results to the first n rows. So let's take an example of a few queries that we typically write to query a relational database like Postgres or your MySQL. So select last name, first name from sales rep, order by last name. So here the select is selecting two columns or attributes, the last name and first name, from a sales rep table, and we are ordering the results. Let's take a look at another example, which is adding a filtering condition. So here we are selecting department number, name, salary from personal.employee. So the personal.employee means in a particular database, we are looking at a particular table. So the personal is the database and employee is a table within the database where department number in so we are looking for department number only employees name and their salaries whose department number is 100 or 500, and we are ordering by department number and name. So let's take a deeper look at some of the filtering clause, which is the where clause, right? So in where clause, we can use a lot of basic comparison operator such as, hey, employee number not equal to something, right? Or it is greater than, less than, where the salary is greater than. So all of these comparative operators can be used in a where clause. Other than comparative operators, you can also use a few of these comparison operators, like the example we saw, where in, so department number in found in a list of items, right? Where salary range is between a certain range, within a range of values. So whereas not negates a condition, we can look for where a particular column match like a particular pattern, right, contains a particular item. And if you want to do a match which disregards the case sensitiveness, then we can use I like. And then you can do a lot of string matching. So because your columns can be string values as well, right, not just numerical. So you can do wildcard characters like percentage or underscore. We'll see some examples. Let's look at some SQL examples where the different where clause conditions have been implemented. So select star from employee where department in IT or finance tells us to select all the columns from employees where the department column in the employee table has the values IT or finance. Similarly, if you want to negate a condition, right, so you say department not in IT or finance. Right, here we are selecting all employees where department are not in IT and finance. So then we can also look at select star from employee where salary is between 80,000 to a lakh, right? So both values are included when we are looking at range. So when we are looking at numerical range, we prefer to use between. So select star from employee where employee name is like. So we want to extract all employees starting with A, and the underscore stands for a single character, whereas the percentage stands for a set of all characters, right? So here we are essentially looking for any employee whose name starts with a capital A, because here we are using like. Here in the next query, so if you have a products table, so you select star from products where product name I like clock, which has a percentage on both sides in the string matching, right? So which means your product name should contain the word clock, and it need not have clock with a capital C. It can be with a capital C, can be with capital L. So the case is not looked at, but the order of the word CLOCK is looked at, right? And it retrieves all the columns. So here we are looking at all the columns in the product table, all right? So another example is it's sometimes you also tend to have null values in your table, right, where your data is not given or it's not entered. So in that case, so let's say you want to look for employee ID and employee name from employee table, where the postal code of the employee is null, right? Probably the employee did not give their postal code, right? So then we can't say postal code equal to null, it will not retrieve it. We have to say is null. All right, so here are some examples for the where clause. So next, let's take a look at group by and having clause. Group by helps us to aggregate. It indicates the dimension on which you want to group your data by, and there are different aggregation functions you can use with the group by. So you can count, you can do average, minimum, maximum, sum, etc. And then having is different from where is when you are directly filtering using a column value in a table, whereas having is when you are filtering using the aggregated value. So let's see an example. So if we want to select the gender and average weight from the employee table, group by gender, right, having average weight greater than 1.5. So that will return from the employee table, it is going to return us two columns, gender and weight. So for each gender, male, female, non-binary, it's going to return, so there might be other gender values as well, but it is going to return to us only all of the gender where the average weight is greater than 5.5 for this example, right? So you can see how it sort of helps you to aggregate. So there could be multiple employees who are male, there could be multiple employees who are non-binary. So it sort of takes the average across all of their weights to get the average weight. Let's talk about SQL joins. So joins are used in SQL to combine data from multiple tables. Typically, if you want to do any sort of reporting, you are trying to combine data from multiple tables. A join combines the columns from the table using the common unique identifier, which is the key, right? So let's take a look at your orders table, which has order ID, or customer ID and order date, and your customers table, which has the customer ID, customer name, contact name and order. So if you want to ship a certain order to the customer, particular customer, then you need to join these two tables, right? So you can see that it combines the columns from the customers and the orders table to put it together. So there are a few different types of join. The first kind of join is called the inner join, and this is the most common. When we say join, it refers normally to the inner join. So inner join returns records that have matching value in both tables, right? So here joins are often represented using Venn diagrams. So you can see there is a left table and right table. Join or inner join always gives us the rows which are intersecting, which are both in the left and the right table. Whereas your outer join or a full join returns all records when there is a match in either the right or the left table. Okay, so we'll see an example for each of it. Whereas your left join, it returns all records from the left table and matches the records from the corresponding right table. Whereas your right join returns all records from the right table and the matched records from the left table. So this Venn diagram is always a good pictorial way to remember joins. Remember the intersection or each of these circles refer to the set of all rows in each of the table, right? So the intersection refers to the rows which are common in both left and right, whereas left join refers to all the rows in the left table. So let's take a deeper look at inner join. So typically, how do you write the query for an inner join? You select the columns from the different tables that you are interested in. So select orders.order ID. So from the orders table, you want order ID. From customers table, you need customer name. From orders, you need order date. From orders, join customer, and we have to specify on what condition should it be joined, right? So on orders.customer ID is equal to customer.customer ID. That is the foreign key relationship in this table. So we have some examples here. So we have an orders table which have different orders 10308, 10309, 10310, and the corresponding customers. So an inner join looks at the orders, goes, so customer 2 is the first customer, right? So it goes to the customer name, which is Anna in the customer name, and looking at the corresponding order date, right? So here you will see the inner join gives you all of the information from which is intersecting. So in this case, it just happens that both these tables, we have the same customers in both these tables. So now let's take a look at your left join. So you are looking at the same set of two tables, your orders and customers, right? But now you are doing a left join on customers on orders dot. So first you start with orders, left join customer, which means orders becomes your left table and customers become your right table. So you are interested in all of the orders in your orders table, right? So here this is where the left table, which is the orders table, needs to be all the rows of the orders table needs to be retained, right? So here if you see customer ID 5 is not available in the orders table. In the customer table, customer ID 5, sorry, is not available in the customer table. So there is a null that gets filled in that place. Whereas your right join, the same thing. So from orders, right join customer on orders.customer ID equal to customers.customer ID. So in this case, your left table is orders, your right table is customer, right? So now you are looking at the right join. So which means all the rows in the customer table will be given as a result, right? So here if you look at it, so you have for customer ID 1, there is no order. So the order ID is null, right? And the customer name Alfred and order ID, order date is null. Whereas for Anna, there is an order, right? 10308. And for Antonio, there is an order which is 10309. And the customer ID 5 is not included because we are doing a left join. So you can see with left and right join, the number of rows that get returned in your output makes a difference. So now let's look at the complete or outer join, full outer join, right? So you have orders, outer join customer on orders.customer ID equal to customers.customer ID. So you have your orders and customer table. So there are some customers in the orders table which don't have IDs in the customer table. There are some customers who don't have orders, right? So now we sort of put them both together. So your outer join gives you combines both the rows of both the tables, all the rows of both the tables, right? So wherever the corresponding values in a particular table is not there, then the null value is added. So here you can see, for example, for Alfred customer 1, there is no order ID. So this becomes null. Similarly, for customer 5 is not there in the customers table. So the customer name is null. So each of these rows, order ID, customer name, order date, right? So these three are based on these values. We are looking only at a subset of each of the table. So then as we start writing queries, it's very important to remember some of the best practices, right? So whenever we write a query, it's important to follow the SQL order of operation. You want to select specific fields or specific columns instead of just doing select star. So some of the examples we saw earlier, all of it did select star, but especially when a table which has multiple columns, the performance of your query increases when you use specific columns. So you want to filter one or both of the table with a where clause in the same query as the join, right? So only if you want to have certain conditions in which you want to join the table. So depending, of course, on your server environment, it might save time. So having statements are calculated after the where. So where is for any condition on the column, whereas having is condition on the aggregated value. Okay, so having is calculated after the filtering happens on the column values. Especially when you're testing joins, right? Always try to use limit. You want to limit the number of returns. So you can limit 5 to just see if you're got your joins correct, right? To control your query sizes. Finally, if you there might be missing data in your database, so you want to say is null or is not null to test for nulls in the column and not say equal to. So to summarize, in this module, we looked at structured query language and understood some of the positives and negatives of a declarative query language, right? SQL is a declarative query language which is used to retrieve, mostly used to retrieve data from these databases. And we also looked at the query order of construction with some examples. And then finally, we took a look at SQL joins, right? So I will see you in the next module. Thank you.